In lecture exam 2, we're going to be talking about the cardiovascular system. So in chapter 18, we're going to focus on the heart, and then in chapter 19, we're going to focus on blood vessels. So I like to incorporate this slide for lecture exam 2, even though I already kind of talked about this for lecture exam 1, because the cardiovascular system has a lot of heavy physiology in it. Recommendations, if time permits, is that you go in and you read the chapter ahead of time before you actually begin studying. Not to take any notes or to write anything down or to necessarily learn anything, but just to get an idea of kind of how the cardiovascular system works. Then go in and study your PowerPoints. So remember I mentioned that the Pearson stock slides have over 400 slides per chapter, and I've narrowed each chapter down to 100 slides or less. So what's in the slides is really the core of what you need to know. I've already trimmed all the material that wouldn't be tested or that I don't find relevant to the A&P2 course. So once you've studied the PowerPoints really well and you know all the information in there, then you can go back and reread the chapter to help tie all of those pieces of information together, and then take additional notes if needed. Study guide, students tend to use the study guide incorrectly. It's just a guide. I don't recommend that you fill it out, because if you fill it out and you study that, you're going to miss a lot of other information. So my recommendation to you is to read the bullet points off of the study guide, see what you can recall from memory. If you can't recall anything, that's going to indicate that you need to go back and take a look at that area. Tips for the cardiovascular system, as well as some other chapters. Drawing diagrams can be really helpful, diagrams or flowcharts. Go to any directed study that is available or free tutoring session that you have. These are free resources that you have, and most students do not take advantage of them. Also, you can find a study partner. Students who study in a group tend to be more successful because they encourage and motivate each other. And of course, always ask for help if you need help with anything. Okay, so the heart is a vital transport system, and it's composed of two side-by-side pumps. What they're talking about is the left side of the heart and the right side of the heart. Those are your two side-by-side pumps. And these are going to work together to circulate blood throughout our entire body. So the right side of the heart is going to receive oxygen poor blood that's returning from the body tissues, and then it's going to be pumped to the lungs through what we call the pulmonary circuit. So once it's in the lungs, our carbon dioxide that we picked up from our tissues is going to be exchanged for oxygen. The other pump, the left side of our heart, is going to receive oxygen-rich blood from the lungs, and it's going to pump it to the rest of the body through the systemic circuit, and it's going to deliver oxygen and nutrients to our tissues and organs. So the heart has 4 chambers that help support this dual circulation, and the right atrium is going to serve as our receiving chamber for low-level oxygenated blood returning from the systemic circuit. And our left atrium is going to receive heavily oxygenated blood returning from the pulmonary circuit. So the atria are our receiving chambers. The ventricles are considered our pumping chambers. So the right ventricle is going to pump blood into the pulmonary circuit towards the lungs, and our left ventricle is going to pump blood into the systemic circuit to help supply our body tissues and organs. So we do have some coverings over the heart. So protecting the heart is the fibrous pericardium, and this is a tough outer layer that helps anchor the heart to surrounding structures. It's also going to help prevent overfilling and provide a little bit of mechanical protection. Surrounding the heart is the pericardium, and this is a double-walled sac made up of 2 layers. So you might remember the visceral and parietal pericardium from A&P1. So the outer fibrous pericardium is lined by the parietal layer of the serous pericardium, while the visceral layer, which is also called the epicardium, lies directly on the heart's surface. And between the parietal and visceral layer is a pericardial cavity, which is just a fluid-filled space that helps reduce friction between the heart and its surrounding tissues, because our heart is constantly moving, so it's contracting and relaxing. And the heart wall is going to be composed of 3 distinct layers. So the outermost layer is the epicardium, which is also referred to as the visceral layer of the serous pericardium. And beneath it's going to lie the myocardium, myo meaning muscle. So it's made up of spiral or circular bundles of contractile cardiac muscle cells. Embedded within the myocardium is the cardiac skeleton, and this is just a dense network of connective tissue that helps anchor muscle fibers. It's also going to support major vessels that we have and the valves as well. And it's also going to help restrict that path of electrical signals to make sure that we have these really nice organized contractions. The innermost layer is the endocardium, and it's a really thin, smooth lining, and it's going to be continuous with the inner lining of blood vessels. So it lines the heart chambers, and it's also going to cover the cardiac skeleton within the valves itself. So this image is in here to kind of give you a little bit of a visual for the information that we're talking about. This is mostly going to be useful for when we're talking about when you're having to identify these structures in lab, because you will need to recognize and identify the majority of these blood vessels. Okay, so the pulmonary and the systemic circuits, they're driven by the coordinated action of the heart's receiving and pumping chambers that we just talked about. And the right atrium is going to receive that low-level oxygenated blood from the systemic circuit, while our left atrium receives heavily oxygenated blood returning to the heart coming from the lungs. The right ventricle is then going to take the blood and pump it into the pulmonary circuit, and then the left ventricle pumps it into the systemic circuit. The atria are really small, thin-walled chambers, and they don't contribute a whole lot to the force of the blood movement. The right atrium is going to collect blood from 3 major veins. We have the superior vena cava, meaning coming from above the diaphragm, and we have the inferior vena cava, meaning below the diaphragm, as well as the coronary sinus, which is draining blood from the heart muscle itself. The left atrium is going to receive heavily oxygenated blood through 4 pulmonary veins. There are 2 on the right and 2 on the left. They don't have specific names that you need to know. The ventricles have a lot thicker muscular wall than the atria because they serve as the main pumping stations. So we can visually see that here. Here's the wall of the left ventricle, and then here is the wall of the atria. So because they're responsible for pumping and actually need to contract at a greater amount, the myocardium, the muscular layer, has to be much thicker in order to do this. So the right ventricle is going to pump blood into the pulmonary trunk, which is going to lead to the lungs. And then the left ventricle pumps blood into the aorta, which is the largest artery in the body. And the aorta is then going to distribute the heavily oxygenated blood to the entire systemic circulation.